In this example, we use a system of two equations and two unknowns to solve an interest problem. So let's take a look at the problem. An investor splits $10,000 between a safe fund at 5% and a risky fund at 20% interest. So that's our first equation, and I'm going to define my two different quantities. I'm going to let S be the amount in the safe fund, and I'm going to let R be the amount in the risky fund. So when we look at the quantities, the safe amount and the risky amount, the first thing that we see is that the investor splits $10,000 between these two funds. So the first equation that we can create is that the amount in the safe fund plus the amount in the risky fund is equal to $10,000. Next, we're given that $1,100 in interest was earned, and that's a total amount of interest. So we'll put 1,100 over here. And that $1,100 is the sum of the interest that's generated by the safe fund plus the interest that's generated by the risky fund. And so at 5%, the interest that comes from the first fund is going to be 5% or 0.05 times S plus the amount of money that's generated by the risky fund, which will be 0.2 or 20% times R. And that total amount again will add to $1,100. So now we have two equations and two unknowns, S and R, and we have a choice here. We can either solve this by substitution or by elimination. So I think that I'm going to try solving this by substitution, and that means that I'm going to isolate one of the variables. So I'll isolate the S in the first equation. This is easy to isolate because it has no coefficient, no number here, and that means that we don't have to divide and get a fraction. So I've got that S is equal to 10,000, and then subtracting the R from both sides, I get minus R. Next, with substitution, I will take that value of S that I've isolated and plug it into the second equation. So I have now 0.05 times, and again, instead of putting in S, I'm going to plug in this substituted expression, 10,000 minus R. So that's the first term in the second equation. And then I still have plus 0.2R is equal to 1,100. Now you can see that we have an equation that has only the variable R. So we can simplify this by multiplying through. 0.05 times 10,000 is going to give us 500 minus 0.05R plus 0.2R is equal to R 1,100. And combining the like terms, 0.2R minus 0.05, we can think of that as 20 minus 5, gives us 15 hundredths or 0.15 R. And I'm going to subtract the 500 from both sides, and so this is equal to 600. And finally, solving for R, I divide by 0.15. And I end up then that R is equal to $4,000. So to answer the question, how much was in each fund, we've got $4,000 in the risky fund and then in the safe fund. We're just going to go back to the original equation that if R is $4,000, S is going to be 10,000 minus the 4,000, and that's going to give us $6,000. So this is how we would solve it using substitution. If we wanted to, we could solve the same problem by elimination. So let's do that. So by elimination, we're going to have the same two equations. S plus R is equal to 10,000, and also 0.05S plus 0.2R is equal to 1,100. When we do elimination, what we want to do is match the coefficients for each of the variables so that one of the variables will drop out. And in the first equation, we don't see a 1 in front of the s, but we can write 1 there. Same thing with the r. We don't see explicitly that the coefficient is 1, but we can assume it to be 1. So as we look at the coefficients of the second equation, we want to think of a multiplier that will allow us to multiply the numbers so that they equal 1, which will cancel either the 1 in the s term or the 1 in the r term. And here, this 0.2r we can think of as being 1/5 r. So if we multiply 5 times the 0.2, we will get 1. So let's multiply that second equation by 5. But also, in order for this term to drop out, we need to have opposite sign, a positive 1r and a negative 1r. So we need to multiply all the terms in the second equation by a negative 5. And again, negative 5 times positive 0.2 will give us a negative 1. Negative 1 will cause the positive 1r term to drop out. So distributing the negative 5 to each of the terms, we get negative 5 times 0.05 is negative 0.25, so that's the coefficient of s. And then negative 5 times a positive 0.2 gives us a negative 1, and that is the coefficient of r, is equal to, and then we get negative 5 times 1100 gives us a negative 5500. Next, I'm going to rewrite the first equation under this modified second equation. So I've got 1s plus 1r is equal to a positive 10,000. And when we put the terms together, we add on both sides. You can see a negative 0.25 and a positive 1s is going to give us a positive 0.75s. And then the r terms, positive 1r and negative 1r, will drop out. And 10,000 minus 5,500 is going to give us 4,500. And finally, we can solve for s by dividing by 0.75. And we end up eventually with s is equal to 6,000. Finally, to finish the problem and determine how much was in each fund, we've got s is $6,000, which is the amount that's in the safe fund, and then the amount in the risky fund. We can take 10,000, subtract off the 6,000, and we get $4,000. So if we compare the amounts that we get for each of the two methods, we do get the same results, although the order in which we find the two variables is reversed.